Hi everyone, welcome to Code Stream CPP. Today we are going to discuss an algorithm which is based on number theory, which is Sieve of Eratosthenes. Basically, the use of this algorithm is to find the prime numbers up to 1 crore. So, why 1 crore or why 10 million? The reason is because arrays cannot hold more than, like, usually we don't say that they hold more than 10 crore, 1 crore, because it is a limitation and CPP. And basically the idea behind this algorithm is like we are going to find the square of the, we are going to assume that all the numbers are prime from 2 to 1 crore are prime. Then what we are going to do is we are going to square these numbers, square a particular number, say from 2 to this. Iteratively we are going to square all the numbers from 2 to 1 crore, and we are going to like mark all those squares and the subsequent multiples of that number to be composite. So what happens is that when you do such an iteration, say you're going to say 2, we assume 2 is prime, so 2 we are going to square it. So from 4 to the subsequent multiples of 2, that's 6, 8 and 10, we'll be recording this as marking this as composite, and similarly the numbers between 2 and 4 will be assumed to be prime. So we have 3, then we are going to this is a square, 3 square is 9, and subsequent multiples of 12, 15 and all is composite. Similarly, like between 4, say now we have 4, then 4 we are going to be 16, 20 and 24, 28, 32 etc. prime, I mean marked as composite. So 4 is already composite, so we don't care about that. We have to only check whether it is not composite or not, so we don't consider this case. We only consider the next case is 5. We have to check whether it is a prime or not initially. If it is already marked as composite, we don't care about it. So basically the logic of a prime number is we are going to check which, we are like to check whether the number is prime is we have to find whether any number between 2 to the square root of the number is divisible. Like any like say here, if 100, suppose 100 by I, or no, 100 modulo I is equal to 0, return false for if it is not prime, else return else. Okay, it will return false, or else it will, by default it will return is prime. So this is the logic we are going to use. This is not the logic, this is the idea behind it, that any number is using I square, like if it is divisible from any range like I square till the square root of the number, then it is prime. So why square root of a number? Say we are going to check till square root of 100 is 10. So if you want to check by 11, so 100 by 11 will obviously give a number that is less than 10. So 10 is the maximum bound which we can square, so it's basically the square root of that number. So we're going to write our program. Let's forget about that, and we'll talk about the idea which we used first. So I'm using C++ because I'm very familiar with it. You can implement this in C also. Now we have an array dp, which is going to store up to 1 crore numbers. Initially we assume that, say, okay, now we are going to say void sieve. Initially we assume all those numbers are prime, so for prime you can use as dp1 size of ap and assume that it's all prime. Now we declare I and j. Now for I is equal to 2, I square is less than or equal to, okay, less than, then we are because we are using this property so that we can reduce the time complexity, right? So is equal to I square. As I already told, all the subsequent multiples of I square will be composite. So first we have to check whether it is prime or not. So dp of I means if dp of I is equal to 1, then all the subsequent multiples will be set to 0, right? So that's done. Now say int main, so int n, for I is equal to 2, I less than or equal to n, I plus plus. Okay. If dp of I, c out I, c out and then home. Alright, so I think this will have to work. We will suppose assume okay, this won't work because we haven't called the sieve function. So initially answer will be 0, so we need not care about that. We call the sieve function, so it will calculate all the prime numbers till 100 and return all the, okay, say 100. See, we got all the prime numbers. So basically I think you understood the idea behind it, and if you like this video, then if you have enjoyed this video, just like, share, and I'm not really asking you to subscribe to my channel. It's your wish whether you want to. I will be posting computer science related stuff, programming and algorithms related stuff in this channel. So okay, thank you for your patience though. I would be putting like if you want some more reference related to this, I would be putting the Geeks for Geeks article in the description, as well as the code of this in the description. Okay, thank you.